Hello again. Thank you for joining us. This is Space Nuts. My name is Andrew Dunkley. I know it doesn't sound like me, but I have a cold, so that's my excuse and I'm sticking to it. Coming up on this episode, it is all about space launches and telescopes and communications. We're going to look at the Anglo-Australian Telescope 50 years on, Starship 5's test flight, the Deep Space Laser Communication System that NASA's been testing, and Europa Clipper is off the ground. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to unravel all the ravelment of space science is Professor Fred Watson. Hello, Fred.
Hello. Good to see you again, Andrew. Yeah,
Gotcha.
Jinxed each other.
Yes, indeed. I've been overseas. I know that people probably don't realise that, but I think we alluded to it in the last few episodes that we were doing catch-ups to try and maintain the momentum, so we didn't miss any weeks. But I've been to Turkey, which is what we call it, but it's Turkiya in that particular country. And, you can say Europe or Asia. Which one do you choose? I mean, the country spans both continents. So, it's a fascinating country, Fred. I loved it there. Loved it.
I haven't been.
I've said, I chose that holiday because I wanted to go to the Gallipoli Peninsula. Mm-hmm. Now, that'll be familiar to Australians, New Zealanders, British, and a few other contingents who did fight on the peninsula in World War I in 1915. But to people from the United States, they might go, Gallipoli, the Dardanelles. It was a plan to take Constantinople from the Ottoman Empire in World War I, and it was an utter disaster. And but it was written into Australian folklore, so it's a sort of a mecca for Australians and New Zealanders to go there because it was essentially Australia's first war as a federated nation. And so I walked the beaches of Anzac Cove and visited the battlefields of Lone Pine. I wanted to see the Neck. The Battle of the Neck was one of the most tragic advances I think the Australians fought in the entire First World War, amongst many, but it was a hiding to nothing. They just did not have to stand a chance because they were running across ground that had cliffs on both sides, as wide as 3 tennis courts, and they were up against machine guns, and they just didn't have a hope. And now that I've seen it, I can see the problem. I didn't really, you've heard the stories, but yeah, quite incredible. Went to Chunuk Bair, right up the top, which is where the New Zealanders got, and that's as far as the Allies ever got in the Gallipoli campaign. They could see the Dardanelles, which was the target, but they never got near them. And then we visited all sorts of other places, some incredible ruins, including the famous city of Troy. And then we spent 7 days out on a boat on the Mediterranean, just flitting around from port to port or cove to cove, swimming and relaxing and telling silly stories to each other and eating up a storm. It's great. Fabulous country. Loved it. Istanbul is just amazing. But so are some of the other places you'd probably never heard of, like Fethiye and Kash and places like that. Well worth a visit. I would go back tomorrow. Yeah. So what have you been up to while I've been away? You've been busy.
Yeah, just a few minor, plans shaping my entire future, which we won't go into at the moment, but there might be news down the track. But more especially, and it'll lead into our first item, I think. We've recently had a symposium to celebrate the 50th anniversary of the Anglo-Australian Telescope, the largest optical telescope on Australian soil, together with the annual Siding Spring Starfest, which is the open weekend that always happens at the beginning of October.
Yeah, which I went to a couple of times over the years, but I was away for this one. And look, 50 years is an incredible achievement, but for 20 of those years, you were in charge of that place.
That's correct. And actually... and
that's how we met.
It is how we met. That's right, when I was astronomer in charge there. So, yes, it's, as I said, the biggest telescope on Australian soil, a mirror 3.9 metres in diameter, and sits on a mountain in the Warrumbungle mountain range. Warrumbungle is a Gamilarey word. It means crooked mountains.
Sure is.
And that's not very far from where you are now. And, yeah, they are very crooked. So we had a lot to do with each other. But what a lot of people in the astronomical community don't realise, because they've no idea that I am actually 190 years old, but I was involved with the Anglo-Australian Telescope before it was even built. Because my first job in astronomy, and the only time I've ever worked for a private company other than with casual student jobs, I was an optical physicist, fresh out of university, at a company by the name of Sir Howard Grubb Parsons and Company Limited, which was founded back in the 1830s, or its original version was. And that was the company that got the contract to build the telescope itself. That's the what we call the tube, even though it's more like it's an open framework, and the optics. They had the contract to do that. The mounting of the telescope, the bit that pointed around the sky, was built by the Mitsubishi Corporation in Japan, who you may have heard of. And my job, this is back in 1969, was just after the casting for the mirror. So the mirror is made of not glass quite, it's a glass ceramic material called Servit, which has zero expansion coefficient, which means that as the temperature changes, it doesn't change its shape. Quite a revolution at the time, because as the temperature warmed with older-fashioned telescopes, you had to refocus them and do all sorts of things. But Servit changed all that. So this 20-ton casting, 3.9 metre diameter casting of Servit material, was cast in Ohio, which is where Owens, Illinois, despite their name, where they had their glass factory. My boss at the time went to inspect this glass blank in 1969 and came back saying it's all good. There are no flaws with it that will compromise its becoming a perfect mirror. And it's coming back to the United Kingdom where I was working. What we need is a proper mat for it to sit on while the optical polishing is taking place. And it's more than a mat, it was an airbag. So this was two thick pieces of polyethylene welded together around the edge, 3.9 metres in diameter, to be filled with air under high pressure when the mirror arrived, so it could sit on that for the optical surfacing, which actually took about 4 years, and removed something like 4 tons of material. The finished mirror was 16 tons, delivered in 1973 to the observatory. I didn't actually make the airbag, but I did start the work on the airbag. Remember these huge pieces of black polyethylene? That was my part in the origins of the Anglo-Australian Telescope. As you said, it very quickly became an icon in its own right. It was commissioned it was actually opened. In fact, as we are recording this on the 16th of October, 2024, it was opened 50 years ago today by a gentleman who simply signed his name Charles in the visitor's book and has now been promoted. He is His Majesty the King. He opened it, and that's what we're celebrating with that anniversary. It went into service in 1975, immediately became one of the leading telescopes in the world because it was the first telescope of its size to be completely computer controlled. And that meant it could work very efficiently. And another thing that put it very quickly on the map was the photographic work of my friend and colleague David Malin. Lives not very far from where I'm sitting now in retirement, although he's still active. He perfected the art and science of making true colour images of the sky, which had never been done before. He used a combination of three photographic plates, one taken in red light, one in blue light, one in green light, combined them together to make true colour images. And they became world famous. They were on the covers of books and albums and all sorts of things. But that plus the scientific ability of the telescope is what really put it on the map. And so for 50 years, it's been one of the leading instruments in the world's arsenal of great telescopes.
We nearly lost it, though, didn't we? That big fire years ago.
That's correct. 2013, the 13th of January was the date. The Wombelong fire swept across the top of Siding Spring Mountain and nearly took out everything. The reason why it didn't, one of the reasons why it didn't, was that exactly a decade earlier, almost to the day, not quite, but almost to the day, a similar fire had swept across the Mount Stromlo Observatory in Canberra, which was the parent body of the Siding Spring Observatory. And that did take out pretty well everything. And the bottom line was lessons were learned from that were applied at Siding Spring. So we had ember screens on all the windows. One of the problems with a bushfire is that the embers, the burning embers, get through the windows, they smash the glass, and before you know where you are, you've got a fire inside the building. Doesn't matter how how good it is on the outside, the fire's burning inside, and that's what happened at Mount Stromlo. We were saved from that by the lessons learned, plus the aerial water bombing of the Rural Fire Service as well, which saved a lot of the infrastructure.
They were fabulous. Of course, you and I spent a lot of time on air over those 20 years talking astronomy and some of the things achieved by the Anglo-Australian Telescope, and our transmitters were on the neighbouring mountain.
Yes, St. Cruach.
And our transmitters were under threat from that same fire, and the Rural Fire Service saved our transmitters by bombing it with retardant. The whole top of the mountain was pink. I got some photos of it, and it saved the transmitters. And I actually got into trouble from the ABC because I didn't tell anyone in Sydney that our transmitters were under threat, simply because nobody told me. But that was no excuse, apparently. But Andrew, it was a pretty harrowing time.
You were always in trouble with the ABC.
I know.
As far as
Yes, I pretty well defied political correctness on a few occasions, and got me into some boiling water. But great times, Fred. Great times.
They were. Just very briefly, just to give you a flavour of our listeners, of a flavour of what the telescope did, it had some world firsts. It was the first telescope to see down to the surface of Venus with infrared light penetrating the clouds. It was one of the first telescopes to discover the optical flashes of light from these rapidly spinning neutron stars that we call pulsars. In later years, it made, and still does actually, made huge surveys of the environment of our galaxy in the universe. So we've got, surveys out to several billion light years. I think it's about 5 billion light years now. Originally it was 2.5 billion light years, where you map all the galaxies. And from that, you can deduce the structure. You find there's this kind of honeycomb structure of galaxies, which we relate to the Big Bang. And it lets us learn more about dark matter and dark energy, the actual structure that's imprinted on the universe as a whole. It's still doing that. And the other thing it's doing is investigating galaxies themselves in detail and discovering and characterizing the planets of other stars. So it's right across all these hot topics in contemporary astrophysics. 50 years after it was built. It's pretty good.
It's remarkable, and hopefully it will keep on keeping on. My first and last sojourn into television was with you at the observatory so long ago. They were testing whether or not regional radio stations could become kind of television bureaus. It was somewhat successful. I think they've reignited that policy now. But we did a story about the 2DF, wasn't it? The 2-degree field.
Yes, I think that's right. Yes,
Which was installed there. Yeah, great. It's a great facility. After that fire, you could drive towards Coonabarabran from Dubbo, and you could see this white pimple on the side of the mountain because none of the trees were there. So the observatory stood out like a literal sore thumb.
Yes.
Yeah, it's a remarkable sight driving towards the Warrumbungles, but even more spectacular with all the trees burnt away. It just changed the whole landscape. But congratulations for your part of it, because you were there for quite a significant part of those 50 years. So well done to you and everybody, Fred. Let us on. If you want to read about it, Fred's written a terrific article about the telescope in the Australian Geographic magazine online at australiangeographic.com.au. Fred, let's have a quick chat about SpaceX and their test launch the other day, the Starship rocket last weekend as we speak. Got off the ground. This was a really interesting launch, not only for getting it off the ground, but getting it back in a way that I've never seen before. And when I watched the video, I went, this has got to be science fiction. That's not real. It's computer generated. But no, in fact, they did catch the rocket in like clamps back on the platform. Amazing.
Yeah. Pair of giant chopsticks.
Yes, that's what they described them as.
So I mean, I've been keeping an eye on this for a long time, and because this has been planned for a long time, the idea of capturing the booster, the Falcon Super Heavy, 71 meters high. I don't know what that is in feet, but it's a lot. It is basically the first stage of Elon Musk's Starship project. And that idea of capturing the booster by this extraordinary mechanism of a couple of clamps that grab it as it falls back down to the launch pad where it left from seemed like a crazy idea. They've been talking about it for years, but then this week we actually watched it happen on TV, and it was truly amazing. So just quickly about the rationale for this, Andrew. I think most of the people who catch our podcast will be aware that the Falcon 9 boosters, which are really the workhorse of SpaceX's fleet, they routinely land on drone barges, and they touch down on a flat surface, but they've got landing legs which fold outwards. I've stood underneath them actually in Houston and at Cape Canaveral. They've got ones that have actually flown there. Those landing legs fold out, and the rocket touches down and, of course, doesn't fall over because you've deployed the landing legs and they hold it up. But for the Falcon Super Heavy, it is so super heavy that landing legs strong enough to keep it upright just couldn't be made, at least with the weight penalty that you'd have to take with you up to deliver whatever payload it is you're delivering into orbit. So this really audacious idea of capturing it with these two chopsticks on this structure that they call Mechazilla is amazing. And I don't even think Elon thought it would work first time, but it damn well has done.
Yeah.
And so that flight, it's called Starship 5. It launched from Boca Chica in Texas, the launch site, with the Starship itself, which is the payload. The pair of them, 121 meters tall, incredible.
Yes.
Went up as planned. The Starship itself was injected into orbit. It only made half an orbit, but it was actually at orbital velocity. That dropped under control, actually. It was a soft landing. but not on land. It was in the ocean. I think it was the Indian Ocean, if I remember rightly. While 7 minutes after the launch, the super heavy launch, the booster itself, came back down to Earth where it set off from, was grabbed by these two clamps, and is now sitting there ready to be used again where it needs to be. You don't have to go out the Atlantic to get it, bring it back or whatever. It's where it needs to be used again. So an amazing achievement, almost a game changer, I think, in spaceflight.
Oh, for sure. It'll save them a lot of time and probably a little bit of money in the process too, because the recovery process must be very costly and time-consuming.
Yes,
so,
that's right. Yeah,
if they can make this work time and time again, it'll just it increases the efficiency of the process. So, well done to everybody at SpaceX with that Starship launch, test launch that was so successful and so spectacular. If you haven't watched it yet, just do a search online and find the Starship 5 test flight and watch the video of the landing. That thing just drops like a rock, and just to watch it adjust its trajectory and balance and flight path and just sort of come back to Earth, it's like you're watching a film in reverse. That's what it looks like.
That's right. Yeah,
it's quite incredible. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
That was Fred sniffing, not me.
Did I sniff? Actually, I did sniff. Yes, I do apologise.
It could have been me. It could easily have been me.
I'm usually careful with that sort of thing, but I'm off my guard when...
That's okay. When the jingles are on, it just sort of, you think...
Suddenly you get a sniff. Oh, dear. Embarrassing.
It's all good, Fred. It's all good. Just don't catch what I've got.
No, I'll try to avoid that by being 300 kilometres from you, so that's all right.
Probably not far enough.
No, it might not be.
One of the most important things in space flight and space travel and putting bases on moons and planets, which will probably ultimately happen, probably sooner than we think, is communications. And NASA has been looking at methods of communication that through a series of tests, and they've been very successful with this particular process, which I am still trying to get my head around. But it's a laser data system, and am I right in saying that they've actually successfully sent signals to Mars?
It's the distance that Mars is at. It's not true that they've sent signals to Mars.
Okay.
Well, they might have done, but they've not have come back because there's nothing on Mars to send them back. But the reason why Mars is mentioned in this story is that the distance that have these signals have been successfully received and transmitted, 460 million kilometers or 290 miles. 290 million miles, I beg your pardon. It's the same distance as separates Mars and the Earth when the two are at their furthest apart.
Right, I get it. So not to Mars, but to a distance equivalent to Mars at its extremity.
Yes, it's almost 500 million kilometers. It's an amazing distance. And it's part of a project that is really all about something completely different. This is the Psyche spacecraft, which is on its way to an asteroid called Psyche, which, like so many other things in astronomy, is very close to my heart because Psyche was one of the asteroids that I tested my brand new software on that I wrote for my master's degree back in the 1850s or whenever it was. It was so Psyche's an asteroid that I've known about for a long time. It's of great interest today. Can you remember why it's exciting as an asteroid, Andrew?
Yep.
Good. Well, I'll tell you. It's a metal asteroid.
That's what I was going to say. That I should trust myself.
Trust yourself. Look, you see, that's right. You should put your money where your mouth is, or your mouth where your money is. That might be the right one.
One or the other.
It may be the sort of denuded core of a protoplanet that never formed. So it's thought to be mostly made of iron. There may be other stuff mixed with it, but it's got that density that suggests it is the actual core of a planet that never made it. So Psyche, the asteroid, is being visited by Psyche, the spacecraft. But en route, the spacecraft has been testing out this new technology of optical communications. So what you do is you use a laser rather than a radio transmitter and beam your signals, which are modulated with the information that you want to carry in just the same way as you do with a radio signal. And you pick it up at the other end and you look at what you've got. Now, this is not it's not sort of insignificant technology because the transmitter on the Earth is at a laboratory. It's actually near Wrightwood in California, and it's run by the Jet Propulsion Laboratory. They have a facility at a place called Table Mountain, which is near Wrightwood, and that's got the terrestrial laser transmitter on board, which beams out, wait for it, 7 kilowatts of laser power up towards Psyche. So you've got to have, because Psyche itself has only got a small telescope to receive these signals, you need to beam them out with a huge power, which is why it's a 7 kilowatt laser. Remember that even a strong laser pointer will be about 3 milliwatts or something like that, 2 to 3 milliwatts. So 7 kilowatts is a lot. The spacecraft receives those with its little optical dish and can then beam signals back. Now, because the spacecraft doesn't have a 7 kilowatt laser on board, it means that at this end, if you're trying to get the signals back from the spacecraft, you've got to have a big telescope. And in fact, what they've been using is an instrument that for many years was the biggest optical telescope in the world, the Hale telescope at Mount Palomar, not far from San Diego in California. It's a 5-meter telescope, 200-inch. When I was a lad, it was by far the biggest telescope in the world. There were pictures of it everywhere. It was very prominent in history. And now it's still a fully used optical astronomy telescope, but it's also being borrowed to be used as a ground station for this experiment. What is the point of it? Well, if you can use optical communications from space or even on the ground, you've got data rates that are up to 100 times more than you can with radio frequencies. You can pack much, much more data into your signals. And so it is, particularly for space communications, is being seen as a really interesting way forward for our future in communications in deep space using lasers. These are infrared lasers. They're not visible light wavelengths, but they're still much more capable in terms of their data content than radio signals are.
Aren't lasers amazing? What they can do with them, and like they use them in medicine and radiation oncology. They use them in day-to-day life. They use them, as you said, with pointers, just little things like that. And idiots use them in their backyards to try and interfere with aircraft. I mean, there's
yes, they do. I know.
There's all sorts of. They've become such a very, pliable tool in so many ways.
Yeah, another tool that astronomers use them for is to create artificial stars that their adaptive optics systems can lock onto. So some of the biggest telescopes in the world, in Hawaii, in Chile, have these laser systems that what they do is they shoot out light of a wavelength, the same wavelength that sodium atoms emit. And you'll all remember the yellowish color of sodium lamps, sodium vapor lamps, which that's the characteristic color of glowing sodium. But if you beam a laser up to the upper atmosphere at about 90 kilometers above the Earth, there is a layer of sodium, and you can excite it to glow like an artificial star if you pump it up with a laser. And then you can lock onto that with your adaptive optics system to remove the twinkling effect of the atmosphere. So that's one of the new technologies that astronomers use, using lasers.
Yeah. Not to mention also military applications, but it's a very sensitive subject, so
there's all that too. Yes, that's right.
Say nothing more about that at the moment. Yeah, that's a great story. If you'd like to read all about it, you can do that at scitechdaily.com. And being a NASA project, you'll probably find it on their website as well.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
From one mission to another, from Psyche to Europa Clipper, we could not finish the show without mentioning that it is now up and running. Europa Clipper is a go and was launched this week our time.
Indeed it was. And so far, everything's functioning perfectly. It has already unfurled its solar panels, which I think I'm right in saying are the biggest biggest solar panels that have been used for an interplanetary mission. They're 31 meters long, which is colossal. What's that, 100 feet or thereabouts, isn't it?
Yeah, that's about the size of your average caravan. No, I'm kidding. It's just having
the ones you get behind, you mean?
Yeah, the ones you get stuck behind, exactly.
Yeah. So it's so it's on its way. It's going to enter orbit around Jupiter, even though it's looking at Europa, one of Jupiter's moons. It will be in orbit around Jupiter from 2030 is when it will arrive. It has a 4-year lifetime, and during that time will make 49 flybys of Europa. The water world, the ice world that we know is orbiting Jupiter, a rocky body with a global ocean over the top of it and a layer of ice over the top of that. So every 3 weeks or so, it will sail past Europa, which is why it's called the Europa Clipper, because that's what it's going to do, sail past Europa. And it will, it's festooned with things like ice-penetrating radar and all of that sort of stuff that will allow us to detect what sort of content the water beneath the ocean might have. It will also, we think, like Saturn's moon Enceladus, Europa has plumes of ice coming from its polar regions. And so Europa Clipper will fly through those, and it's got equipment on board that will say whether there are any perhaps suggestions of prebiotic molecules in the water, or even biomarkers. Maybe we might discover that there's something in that water ice that tells you that there is life beneath the icy surface of Europa. That would be the discovery of the century.
I'm still betting on krill. I've got very, very long odds on it detecting whale song. But
that's right. Whale song might be there. Wouldn't that be extraordinary? Yeah.
It'll probably be squid. Science fiction always seems to go to the squid-like discoveries on these kinds of worlds. Yeah.
Maybe just calamari.
Could be, yes. At least they'll have something to eat when we finally go there. But it's very exciting. It's a long mission. If you got a job on this mission, you could be pretty happy because you'll probably be involved long enough to get long service leave. So it's a big mission.
Yes, that's right.
And it'll probably last longer than the 4 years that they've given it, because that seems to be the norm these days with some of these spacecraft. They just keep going. I mean, look at the Voyagers and all those things that are still trundling around on Mars that we thought would, be forever gone long ago, and they're still working. Everything seems to work well past its use-by date these days, which is a good thing. We'll possibly get more out of it, unless they're planning to crash it into something. Fred, are they? I don't know.
I don't know what the end mission is, but you're right. That was exactly what I was thinking, because in some ways it's akin to Cassini, which was in orbit around Saturn, and the reason why it was crashed into Saturn's atmosphere to melt basically by friction is in order to avoid any suspicion of contamination by some of the moons of Saturn that may contain living organisms. So maybe a similar fate awaits, bless you, maybe a similar fate awaits Europa Clipper at the end of its life.
That was my wife.
I guess so.
It's become part of the program that she has to sneeze at least once during a recording session.
I'm just grateful that it wasn't me sniffing.
Yeah. The thing is, she'd probably do about 25 more before she's finished. She only sneezes once a week, but she does them all at once. Gosh. Yeah, that's a great story. And Europa Clipper on its way. So sit back, relax, get yourself a pina colada, and we'll get back to you in 2030. So...
Yeah, we probably will. That's the daft part about it.
Yeah, no, you've got to be patient. You've got to be patient. Yeah. You can find that story on the nasa.gov website. We're just about done. Don't forget to visit our website as well while you're online, spacenutspodcast.com, spacenuts.io, and have a look around. Don't forget we've got the Astronomy Daily news feed there that you can subscribe to. You can communicate with us via the AMA link up the top there. You can visit the shop if you've got... Christmas is coming up, you know. If you've got astronomy nuts in the family, you might find something really juicy there that you can get somebody for Christmas, whether it's a T-shirt or a cap or a book or there's all sorts of stuff there. SpaceNutsPodcast.com is the site. And we are done, Fred. Thank you so much.
It's a pleasure. Thank you for having me, and great to see you again, Andrew.
Always good to have you along, Fred. Otherwise, I'd be sitting here just doing that, you know, getting RSI of the thumbs. Yes. Thanks, Fred. Fred Watson, astronomer at large, and thanks to Hugh in the studio for being so very patient and sitting back for 4 weeks waiting for me to get back from Turkey. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.